Hello everyone, welcome back. So today's topic is real number. Before than that, I want to tell you that my name is Smith Mishra and this is my second lecture, that is topic on real number, which is the first chapter of CBSE class 10 mathematics. So first understand what is a real number. So a real number is something which is having points or decimal. So any number which is in decimal format is the real number, like 1.1, 1.2, 1.3, 1.31, like that, etc. It can be 2.2, 2.21. So anything that is having decimals are called real numbers. So if we are talking about graphs, so of course it can be positive as well as negative also. So like minus 1.12, minus 1.13, all these are real numbers. 0 is also a real number. So of course, what is the difference between then integers and real numbers? So integers, if you will see, it's just like a positive or negative counting numbers. You just minus 1, minus 2, minus 3, but there is no decimal in between. But if I talk about real numbers, so it's having decimals. So like suppose we know this graph things. So let's draw first and then understand. So this is my origin. Oh, this is 1, 2, 3, 4. This is minus 1, minus 2, minus 3, minus 4, like that. So if I will talk about integers, it will be the points 1, 2, 3, 4, or here minus 1, minus 2, minus 3, minus 4. But if it is between 0 and 1, there are infinite number of real numbers. Between 1 and 2, there are infinite number of real numbers. So real numbers, if we are telling that to draw a real number between 0 and 1, so here we have to give this as a straight line. We can represent it like this. So between 0 and 1, we have infinite number of real numbers. Similarly, between 1 and 2, or between 0 and 3, we have infinite number of real numbers. So we represent graph as a real number as a straight line. So we should draw between which point we are being told, and then we will draw a straight line between that 2 points. So they are called real numbers. Okay. Now let's move on to our topic. So the first thing in the real number is Euclid's division lemma. So Euclid's division lemma. So what is Euclid's division lemma say? Euclid's division lemma. So first understand what is lemma. So lemma is a proven thing, a proven statement which is used to prove any other statement. Got it right? So lemma is a proven statement which is used to prove another statement. Similarly, there is a terminology called algorithm also. So what is algorithm? So algorithm is also a set of steps. A set of steps which will make a procedure to solve the problem. So if we have a given problem, we will design a set of steps to make a procedure so that that problem will be solved by that procedure. So that are called algorithm. So generally these two will be used interchangeably in this chapter, Euclid's division lemma, that is chapter 1.1 of CBSE class 10 mathematics. So don't get confused if it is lemma or algorithm, both are same only. Okay, so let's now understand what is. So let's now understand what is Euclid's division lemma. What are the things that has been clarified over here? So what we will get with Euclid's, what it says. So Euclid's division lemma says that if a and b, we have two given integers a and b, then there exists two unique integers q and r. So a and b we have given integers, okay. Then there exists two unique integers q and r which will satisfy the equation a equals to bq plus r. Okay, of course a is greater than b. If given integers a and b, where a is greater than b, then as per Euclid's division lemma, there also exists q and r such that a equals to bq plus r and 0 is less than equals to r is less than b. Understand, this is very easy things to understand. So we have two given integers a and b such that a is greater than b. Then Euclid's division lemma says that there exists two unique integers q and r such that a equals to bq plus r and 0 is less than equals to r is less than b. Simple as that. So this is used to find the HCF of two numbers. Okay, so what are the steps? So what are the steps to get the HCF of two number? Of course, so we have same way. We have suppose a number a and b, and we have two integers a and b, and a is greater than b. So the first step is represent a as bq plus r. Okay, represent a equals to bq plus r such that 0 is less than equals to r is less than b. Okay, second is, so the second step says okay, so where 0, so this is our first step, a equals to bq plus r. So this is then the thing is, once we are done with it, if suppose r equals to 0, then b is the HCF of a. Okay, HCF of a comma b if r equals to 0. Now if r equals to not 0, if r not equals to 0, then what? Then we will again take b equals to b equals to RC plus D. So there must be some integer C and D which will again there. So this type we need to continue like this. So this is our third step. If R is not equals to 0, then we have to take for this divisor B and remainder R, that we need to again apply the Euclid's division lemma. And we will get some two unique integers again So this is a continuous thing we need to do until and unless r is not equals to 0. That means the quotient, the remainder is not equals to 0. Till then we will continue the process again and again. Okay, so let's start the problem. So let's do chapter 1.1. Okay, so let's do our chapter 1.1. So I will make it clear first. Okay, so first I'll do exercise 1.1. We are doing from the CBSE class 10 mathematics book. Okay, so the first problem is use Euclid's division algorithm to find the HCF of first is 135, 225. How we will do it? So here you can see that 225 is greater than 135, correct? So now we have to apply the Euclid's division algorithm. So let's take a rough. There we will divide first. Okay, we will divide by 135. We will get 135 into 1 is 135, then 0, 9. So as you can see, this 225 can be represented as 135 into 1 plus 90. See, we have got Q and R over here. So here Q is 1 and the remainder is 90. Okay, so here 135 is the divisor. This is our dividend. 225 is dividend, 1 is quotient, and 90 is remainder. Remember this. So divisor is something with which we divide. Then dividend is something which is getting divided. Quotient is what we get after division. And remainder is the after subtraction. If it is not fully divided, then after subtraction, whatever number you get, that is the remainder. Okay. So here you can see that 225 is represented as 135 into 1 plus 90. So this is of the form 135Q plus R, where Q is 1 and R is 90. You can see this. So, and also 0 is less than equals to R is less than 135. Okay, 135. So you can see this. So division lemma we have applied over here. So here Q is 1 and R is 90. Then you can see remainder is not 0. So we will proceed again with this divisor and remainder. So 135, now I have to write it in the form of 90 as per division algorithm or division lemma. So 90, so 135 is divided by 90. So 1 again 90, we get 45. So 135 can be represented as 90 into 1 plus 45. So again you see this is of the form 90Q plus R, where 0 is less than equals to R is less than 90. Can you see this? So it is again of this form. So this is our second line. Next, see again we got again R as remainder as 45. So we will not stop here. We will move next up to we don't get remainder as 0. So let's now again we'll take this divisor and remainder. So 90 we have to represent in the form of 45. So 90 we know it is 2 into 45. Let's do it over here. I'll show you. 45, 90, 45 2 ja 90. So we got remainder as 0 over here. So it is 45Q plus R. So we have got R equals to 0 over here. Hence our HCF will be 45. So our HCF is 45 for 225 and 135, which we got as per division lemma algorithm. Okay, next. So the next problem is 196 and 38220. So let's do next problem. So second problem is 196 and 38220. The second problem is 196 38220. Okay. So here you can see that 38220 is greater than 196. So I have to represent 38220 in the multiple of 196 and some remainder. So of course that means 38220 equals to 196Q plus R, where 0 is less than equals to R is less than 196. Okay. So let's divide. Let's divide 38. So division you should do in the rough. Don't do in the main page. This is just for your understanding purpose. I am doing it over here. So let's divide. So 196 38 220. So 196 1 ja 196. We got 6. 18 minus 9 9. 7 minus 17. So 17 minus 9 8 and 2 minus 1 1. 186. So we will get 2 9 ja 9 6 ja 54 5 9 9 ja 81 5 86. So 8 9 1 ja 9 8 17. So we got 12 minus 4 is 8. 15 minus 6 is 9. Now we'll get 0 5. So 6 5 ja 30 0 3. 9 5 ja 45 48 4 5 1 ja 4 9. Yeah, so you can see this, we have got 195 and it's getting properly divided, so there is no remainder over here. So 38220 can be represented as 196 into 195 plus 0. So we got remainder as 0 in the very first step itself. So our HCF will be 196. So divisor will be the HCF. Okay. So I hope you understood this. So let's do the next problem. So the next problem is same Euclid's division algorithm we need to apply to find the HCF of 867 and 255. 867, 255. Okay. So you can see that 867 is greater than 255, correct? So we have to represent 867, 250. So as per Euclid's division algorithm, plus R, where 0 is less than equals to R is less than 255. Okay. So this is as per Euclid's division lemma. Now let's divide it. Let's divide 867 by 255. So 255, 867. Okay. Let's take, why I took 3, because 25 into 3 is 75, so it will come around 75. This 25 into 3 is 75, this is 86, so that's why I multiplied with 3. Okay, this is hit and try method. You can also try it. So 5 3s are 15, 1, 5 3s are 15, 1 16, 1, 3 2s are 6, 1 7. Now 7 minus 5 is 2, 6 minus 6 is 0, 8 minus 7 is 1. Okay. So 867 can be represented as 255 into 3 plus 102. Okay. So here Q is 3 and R is 102. Now we will take this in the form of this as per the Euclid's lemma. So as per Euclid's division lemma, 255 equals to 102Q plus R, where 0 is less than equals to R is less than 102. Okay. So now divide 255 by 102. So 102, 255. So 102 2s are 204. 5 minus 4, 1, 5. So I have got 255 equals to, yes, correct. So 255 equals to 102 into 2 plus 51. So we have got Q as 2, R is 51. So still we didn't get remainder as 0. So again we will go for next step. So 102 equals to 51Q plus R, where 0 is less than equals to R is less than 51. Okay. So let's divide now. So 102, 51, 102. So you will see 51 2 ja 102. So we got purely divided. Here remainder is 0. So 102 can be written as 51 into 2 plus 0. So as you can see, remainder is 0. So HCF will be the divisor, 51. So this is the answer. Okay, let's move on. So next problem says, let's clear this first. So next problem says, so this is the second problem. So next problem says that so that any positive odd integer is of the form 6q plus 1 and 6q plus 3 or 6q plus 5 where q is some integer. So let's assume, let x be the positive odd integer. Positive odd integer. Okay. Of course, x is greater than 6. Then only we can represent this. So, as per division lemma, as per Euclid's division lemma, x can be represented as 6q plus r. Correct? Where 0 is less than equals to r is less than 6. That means it can be 0, 1, 2. So r can have a value of 0, 1, 2, 3, 4 and 5. It cannot be 6 or more than 6. Okay. So x equals to then, so it can have either x equals to, so if r is 0, then x equals to 6q. If r is 1, then x equals to 6q plus 1. If r equals to 2, then x equals to 6q plus 2. If r equals to 3, then x equals to 6q plus 3. If r equals to 4, then x equals to 6q plus 4. If r equals to 5, then x equals to 6q plus 5. Okay, there is no more values because r is between 0 and 5. Now, let's check. So, as I have told you in number system, if you have gone through my video, what is even number? So, even number is something which is divisible by 2. So, if I will take x equals to 6q, so 6q can be represented as a form of 2 into 3q. So, as you can see over here, it's a multiple of 2. Hence, it is not a even number. So, this thing not an even number. 6q is not an even number. Okay. Similarly, if we are taking x equals to 6q plus 2, then if you will take 2 common, then it will be, for this 6q divided by 2 is, so 6 divided by 2 is 3. So if you are taking common of 2, I will be left with 3q, then plus, since I took 2 common, so 2 divided by 2 is 1, so I will get 3q. So this again has a factor of 2. So this also is not an even number. Sorry, my mistake. It's an even number. Even first one was also. So this is an even number. Let me. Okay. So we have got as okay. So you can see over here 6q can be represented as 2 into 3q, so it's an even number. Similarly, x equals to 6q plus 2, so this is again a multiple of 2 into 3, so it's again an even number. Similarly, if x equals to 6q plus 4, then 2 into 3q plus 2, so it's again an even number. Then x, no more. So you can see this 3 is even number, but the question says it's a positive odd integer. So x is a positive odd integer. So of course this cannot be an odd because it's an even number. Hence x can be of the form of 6q plus 1, 6q plus 1, 6q plus 3 and 6q plus 5. Okay, I hope you have got this. Okay, let's move on then. Let's move on. So the next question says, an army contingent of 616 members is to march behind an army band of 32 members in a parade. So the two groups are to march in the same number of columns. So what is the maximum number of columns in which they can march? So remember, what is row and column? First let me understand you. So if I'll draw a table like this, so here if you can see A, B, so the vertical things are the column and the horizontal things are row. Remember this, vertical things are column and horizontal things are row in a table. Okay. Now what he is telling is he wants the same number of column out of 616 616 members and 32 members. So this will be again solved by the Euclid's division lemma. So it's simple. I mean, whatever he wants is, he wants you to find the HCF of 616 and 32, because once you will get it, that many number of column will be required. Of course, number of rows will vary. What is same is number of column, because we want same number. So that can be found only when we get the HCF of 616 and 32. So we will apply the same Euclid's division lemma. So as you can see, 616 is greater than 32. So I need to represent 616 the form of 32q plus r, where 0 is less than equals to r is less than 32. Okay, so let's divide them. Let's divide. So okay, so 31 ja 32 1 ja 32, 11 minus 2 is 9, 5 minus 3 is 2, 296. Okay, so 3 9 ja 270, 3 9 ja 27 plus 18. So we will get 288 if I will multiply with 9. So how I did it, I multiplied 30 into 9. So 30 into 9 means 3 into 9 27, put 0 over there. So 30 into 9 is 270, then 2 into 9 is 18. So 270 plus 18 is 288. So 16 minus 8 is 8. This becomes 8. So 616 can be represented as 32 into 8 plus 32 into 19 plus 8. Okay, so here you see remainder is not 0, so we need to represent the previous divisor in the form of remainder as per Euclid's division lemma. So 8q plus r is 0 is less than equals to r is less than 8. So now we divide 32 by 8. So 8 4 ja 32. So 32 can be represented as 8 into 4 plus 0. Now you see we have got this remainder as 0. So the number of column will be, so since HCF is 8, so since HCF is 8, so our number of columns will be equal to 8. That's it. Okay. Let's do the next problem. What is the next problem? So the next problem is use Euclid's division lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. Square of a positive number. So let that positive integer be x. So let the positive integer be x. Okay, so so x can be represented if I can take q as 3. So x can be written as 3q plus r, where 0 is less than equals to r is less than 3. Okay, so r can be 0 1 2. So x will become 3q plus 1 or 3q plus 2. So it can be represented in this two form. Now what will be x square then? X square will be 3q square, 3q plus 1 square, and 3q plus 2 square. Now what is 3q square? Is 9q square. Now this is a plus b whole square. So you know a plus b whole square is a square plus 2ab plus b square. So it will be 9q square plus 2 into 3q into 1 plus 1 square, that is 1. This will be again 9q square plus 2 into 3q into 2 plus 4. 2 square is 4. So x square can be either 9q square or 9q square plus 2 into 3q into 1 is 6q plus 1. 9q square plus 2 into 3 is 6, 6 into 2 is 12, so 12q plus 4. So you can see it over here. So x square can be represented as 3 into 3q square comma 3 into 3q square plus 2q plus 1, and so I took 3 common. If you will see over here, I took 3 common in both till now. So here if I will take 3 common, so bracket I wrote 3q square. Here between this two I took 3 common. So for 9q square I am left with 3q square. For second 6q I am left with 2q, and then finally plus 1. And for this 2 again I will take 3q is common, sorry 3 yeah, so here also I will take 3 common. So what I am left with, 3q square plus 4q, and finally plus 4. Again this 4 is more than 3. So what I will do is, this 4 I can write it as 3 plus 1. Correct? This 4 I can write it as 3 plus 1. So from that 3 I will take 1 common plus 1. So see this, 3 into 1 is 1 plus 1 is 4. So the whole thing is less than 3. That is what my intention is. Now if you will see this, since q is a positive integer, so 3q square will be again a positive integer. Okay, so I can write 3q square equals to m, where m is a positive integer. Okay, or m1 if I can write any positive integer form. You can write k1, k2, whatever you want. Suppose I am writing k1, where k1 is a positive integer. Correct? Because 3q square is a positive integer. Since q is positive integer, so 3q square will be a positive integer. Now similarly 3q square plus 2q, I can write it as k2, where k2 is another integer, is positive integer. Correct? And 3q square plus 4q plus 1, I can write it as k3, where k3 is also a positive integer. Why? Because if you will see, q is a positive integer, so addition, multiplication, subtract, so all things will give you a positive. Subtraction might take you a negative integer, but since it is plus or multiplication, so it will be a positive integer. Correct? So the x square thing can be written as 3k1, 3k2 plus 1, and this also 3k3 plus 1. So see over here, k2 is a positive integer, k3 is a positive integer, so it doesn't matter. So the whole things x square can be represented as a form of 3m and 3m plus 1, Why I took k2 and k3? See, it might be a different, I am not talking about the exact value, but k2 and k3 is also positive integer, and it is of the form of 3 into some positive integer plus 1. So here, hence this both will corresponds to one thing only, that is multiply a positive integer with 3, add 1. That is what intention is. Its value might be different, but it actually corresponds to the 3 multiplied by some positive integer plus 1. So both corresponds to the same thing. So you can see that x square can be represented in the form of 3m and 3m plus 1. Okay. So let's do the last problem. I hope so. Yes. So the last problem says, the last problem is fifth problem. What it says is, use Euclid's division lemma to show that the cube of any positive integer is of the form 9m, 9m plus 1 or 9m plus 8. Okay, very good. So again we will take positive integer bx, positive integer, we will assume positive integer bx, and q is 3 over here. So of course x can be represented. So as per Euclid's lemma, division lemma, we can say that x equals to 3q plus r, where 0 is less than equals to r is less than 3. So x can be of the form 3q. If r is 0, then it's 3q. If r is 1, then 3q plus 1. If r is 2, then 3q plus 2. Now x cube equals to 3q cube, 3q plus 1 cube, 3q plus 2 cube. I am giving comma, you can make it separate also, there is no issue with it. So either it can be, so comma I am representing that either it can be 3q or 3q plus 1 or 3q plus. So you can write a separate line also. I am doing in the same line for your understanding and little bit space constraints also. Okay. So of course x cube, if I will consider this, it will be 27q cube. In second case, x cube equals to, so a plus b whole cube is a plus b whole cube equals to a cube plus 3a square b plus 3ab square plus b cube. Okay. So okay, so we can write x cube so we can write the second thing, x cube equals to 3q whole cube is 27q plus 3a square b. So it will be 3 into 3q whole square into 1 plus 3 into 3q into 1 square plus 1 cube. Okay. So that will give me 27q cube plus 9q square into 3. So it will be 27q square plus 9q plus 1. Okay. So here I can take 9 common. Here also I can take 9 common. So 3q cube. And here I will take 9 common. It will be 3q cube plus 3q square plus q plus 1, and then finally third one is x cube equals to 3q plus 2 whole cube. So it will be 27q cube plus 3 into a square, right? So 3q whole square into 2 plus 3 into 3 into 2 square plus 2 cube. So it will give me 27q cube plus 3 3 ja 9, 9 3 ja 27, 2 ja 54, 54q square plus 3 3 ja 9, 9 4 ja 36 q plus 8. So I will take again 9 common. I will get 3q cube plus 6q square plus 4q plus 8. Now you see in the first 3q cube I will write as k1, because where k1 is a positive integer. Now since q is a positive integer, so 3q cube is also a positive integer. So k1 will be a positive integer. Okay. Similarly, if q is positive integer, then the second one 3q cube. So k2 equals to 3q cube plus 3q square plus q. So if q is a positive integer, so whole things will be a positive integer. So k2 is also a positive integer. Correct? Then finally k3 equals to this one 3q cube plus 6q square plus 4q. Now since q is positive integer, so this whole will be the positive integer. So k3 is positive integer. Okay. So finally we got x cube is of the form what? 9k1 comma 9k2 plus 1 9k3 plus 8. Correct? Where k1, k2, k3 are all positive integers. So, or in other words, we can write that x cube can be, since k1, k2, k3 are all positive integers, so I can write it as x cube can be of the form 9m, 9m plus 1 and 9m plus 8, where m is a positive integer. So the whole things can be represented of the form 9m, 9m plus 1 or 9m plus 8. So we are done with our first chapter. Hope you like the video. If you like the video, so please like it, subscribe it and share with your friends on various social media sites and all. And also if you have any doubts, you can go to my Facebook page. There you can raise your query, or even below also I have kept the communication section open, so there you can raise your doubts, you can clear your doubts. If possible, I'll try to solve, if I mean not 100%, but yeah, most of the time I'll try to look at the things what you guys have any issue. I'll try to solve it as much as possible, but please don't forget to like and subscribe. Yeah, thank you. We'll see you in my next lecture that is 1.2, which will talk about LCM and HCF. Thank you. Bye bye.